Okay, good afternoon. Thanks for joining us. Let's get going. So my name's Simon Brown. I'm an independent consultant specializing in software architecture, and the purpose of the session is to talk about C4 models as code. Who is using C4 here? That's a good chunk of you, but not all of you. Excellent. So this is going to be like a 20-minute talk with the rest of it as being kind of live demos and stuff. So architecture diagrams are historically very, very bad. I'm sure you've all seen diagrams like this kicking around your SharePoint, Confluence pages, whiteboards, etc. UML fixes a lot of these problems, but nobody seems to want to use UML these days. Why? I've literally heard all of the reasons you can possibly imagine. People tell me that you'll be seen as old if you use UML. The tooling's horrible, it's a waste of time, it's not expected in Agile, etc., etc. It's worth noting that most of these are not true. So enter the C4 model. The C4 model you can find on c4model.com. And this is really the premise behind the entirety of the C4 model. If you don't want to use UML or Archimate or SysML, all those other kind of standardized formalized notations, but you still need to draw some architecture diagrams, and you want to use boxes and arrows, try to do so in a structured way, and make sure your notation is self-describing. That's essentially the key principle behind C4. C4 is essentially two things. Number one, it's a hierarchical set of abstractions. The largest of these abstractions I'm going to call a software system. A software system is, to be honest with you, it's the hardest of these abstractions to easily define. But essentially what I mean by a software system is something that we are delivering as a team. It's something that we can see the internal implementation details of. It's something that we have responsibility for, we're supporting, etc. If we look inside these things I'm calling software systems, I'm going to say they are made up of one or more containers. I know Docker's a thing. Forget Docker. Like, this has nothing to do with Docker. I apologize. I got the name first. I know that's totally irrelevant, because Docker is way more popular. By container, I basically mean an application or a data store. So the software systems we build are made up of applications and data stores. React on the browser, Angular on the browser, ASP.NET MVC on the server, Spring Boot on the server, PHP, Python, Ruby, etc., all running on a server. That's what I mean by app. Data store is your relational database schema. It's a folder on a file share. It's an Amazon S3 bucket. It's an Azure Blob Store, etc., etc. If we look inside these things I'm calling containers, specifically the code-focused containers, the applications, I'm going to say they are made up of components. Component is a massively overloaded word, I get that, but by component I want to mean something very specific. A component here is a grouping of related functionality, hopefully a nice, clean, well-defined interface into that functionality, running inside a container. So in this set of abstractions, the component is not the separately deployable item. The container is the separately deployable thing. And if you look inside components, I'm going to say they are made up of code-level elements. So if you are building a C# component, when you zoom inside it, it's made up of enums, classes, interfaces. Java, same thing. C++, same thing. If you are building a JavaScript component, now it's objects and functions. F#, Pascal, functions. So really that bottom level represents the constructs we have in the languages that we're using. And that's the four levels of abstraction. A software system is made up of one or more containers. Containers contain components, that's where the name comes from, and components are made up of code level elements. Once you have that set of abstractions, you can then move on to the second thing, which is a hierarchical set of diagrams. So C4 is named after the hierarchical set of diagrams, and there are four of them. The clue is in the name here. System context, containers, components, and code. And the four levels of diagrams map onto those four levels of abstraction. And it's a kind of zoom in, zoom in thing as you get further down the stack. The concept here is kind of diagrams as maps. So I live in Jersey in the Channel Islands, and if you open up Google Maps and you do a search for Jersey, you are going to get that picture. If you know where Jersey is, because you've seen Bergerac, yeah, I knew that would work. Very big in the 80s for those of you who are too young. If you know where Jersey is, this is great. You can find out where the airport is and the beaches and the major roads and all that sort of thing. If you've never heard of Jersey because you're too young or you never saw Bergerac, you have to pinch to zoom out. And eventually, if you zoom out far enough, Jersey completely disappears because it's tiny. On the flip side, we can zoom in, zoom in, zoom in, and we can drop into something like Google Street View. And Google Street View is a one-to-one mapping with the real world when the photos were taken. So it's different levels of maps that essentially allow us to explore differently. The diagrams, the software architecture diagrams, are essentially the same thing. It's different levels of diagrams that allow us to tell different stories to different audiences. The context diagram, as you'll see shortly, is quite technology agnostic. And as we dive deeper, we get more and more technical details. So as we progress down the stack of diagrams, it's more towards architects and developers. I'm going to explain the top two levels of diagrams before we get into the kind of tooling demos, because it's useful to know what these are. So the top level diagram is a system context diagram. And the system context diagram basically says, here's your system in the middle, and here are the things around it in terms of people and other software system integration points. So in other words, in order to draw a system context diagram, these are the questions you need to ask. What's the scope of the thing we're building? What features sit inside our box? What features sit outside of our box in the rest of the environment? Who is using the system we are building? Actors, roles, personas, real people. What types of things are they doing? And what system integration points do we need to support? Answer those questions, and you can draft up something like a context diagram. This is a context diagram from one of the workshops that I run. The red box, the financial risk system, is the thing that this team were designing. They've added a bit of detail there, and they've correctly identified a couple of user types and some system integration points. So most of these systems are provided by the environment around it. So that's an example system context diagram. It's people and software systems. As developers, we want more detail, so now we can do the pinch to zoom movement, and we can drop down to level 2 and draw a container diagram. This is a different set of questions, essentially, because it's a different diagram showing different things. So the questions are, what are the major technology building blocks? In other words, what are the applications and data stores that make up this thing that we're building? What are the responsibilities of those applications and data stores, and how do they communicate? Answer those questions, and you can draft up something like a container diagram. So you'll notice the big red box has now been kind of zoomed in, and we're showing the applications and data stores, the C4 model containers, that sit inside that red boundary. Here we have some Spring apps, some JavaScript apps, and some data stores. And it's a nice diagram. It's got some responsibilities, it's got some tech choices, some protocols. It's just a nice summary of the overall software architecture. A couple of points to note, the C4 model is notation independent. A lot of people who might have done C4 in the past will tell you that it's blue and gray boxes. That's not the case. You can use any colors. Other colors are available. You can also use other notations. Oh, don't, I've got a whole rant about color coding, honestly. Pin me afterwards. You can also use alternative notation. So if you want to use UML as your notation, that's absolutely fine. So there's nothing preventing you using UML, Archimate, SysML for your C4 diagrams. Why? Because C4 is two things. It's a set of abstractions and a set of diagram types. It doesn't tell you anything about notation. So tooling, this is the big question most people ask me. What tooling do I recommend? If you go to c4model.com, there's a tooling link, and I've tried to list all of the tools that I have found that provide some degree of specific support for the C4 model. And there are, broadly speaking, two categories. There are diagramming tools and modeling tools. So most people use general purpose modeling tools. Quick show of hands, who's using Visio, Draw.io, Diagrams.net, OmniGraph or Lucidchart, Glyphy? Yeah, and the rest. It's massively used. So this is kind of most people's first choice of a diagram tool. These tools are fantastic, but I don't recommend them for drawing architecture diagrams, especially if you're going to use the C4 model, for reasons that will become clear in a second. Reason number one, if you open a diagram in Visio or Diagrams.net, Draw.io, it doesn't know what you're doing. Those tools just see shapes, boxes, and arrows. So a system context diagram really only should show people and software systems. There's nothing preventing you, when you're using Visio, adding things like components to a system context diagram. So this little thing down here really shouldn't be there. There are not many rules in C4, but that's one of them. but Visio can't stop you. If you want a system context diagram and a container diagram in a tool like Visio, you do this by opening 2 tabs and creating 2 diagrams. One of the things you'll notice with C4 is you end up duplicating things like people and software systems across your various layers of detail. How do you do that in Visio? You copy and paste to a different worksheet, a different tab. What happens if you rename the person? Well, now you've got 2 names. Are these 2 different people, or are these the same person? And we just forgot to change one of the names. So the tool can't help you here. It doesn't realize that 2 boxes are the same thing. This is pretty self-explanatory. If you try and export these things to text to stick them in Git, you get an utter mess. This leads on to the next thing, which is they're hard to diff. If you change the name of something, many of these file formats don't show you that change very easily. And most of these tools don't have any sorts of automation APIs. With draw.io, diagrams.net, there is a way to give it a CSV file, and you can have it auto-generate some diagrams, but that's pretty much it. Most of the other tools don't provide much in the way of automation. These tools are also a pain in the ass. We've all done this. Yeah. You notice this text mostly fits, and you're like, yeah, should I add it like a couple of line breaks in there? And if you do, you have to like change the size of the boxes and recenter everything. It's a bit of a pain, and that line's not straight. It's 1 pixel out, and you know what happens? You kind of nudge it, and it's still 1 pixel out the other way. Oh dear. So, back in the heady days of the pandemic. 2020 sometime, I forget when, the ThoughtWorks Tech Radar blipped diagrams as code as a thing that people should look at adopting, trialing. Diagrams as code is essentially a way to create diagrams from text. So rather than opening up a tool like Visio and dragging and dropping using your mouse, basically what you're doing is you're writing some text and you're using tooling to generate diagrams for you from that text definition. The most popular tools in this space are probably PlantUML and Mermaid. There are some others, but predominantly those are the 2 tools you'll see people using. Diagrams as code is awesome because it's easy to author, it's just text. As developers, we like text. We have lots of tooling and IDEs to support text. There are plugins for things like VS Code that do completion and IntelliSense. These are text, so they're easy to diff, easy to version control, and many of these tools have automated CLI-type environments, so you can automate these and push them into your CI/CD build process. So you can have automatically generated architecture diagrams. The most popular tool in terms of kind of like diagrams as code for C4 is called C4 PlantUML. So this is PlantUML plus some macros that some people have built on top. And rather than talking about boxes and arrows and rectangles, C4 PlantUML adds some macros that you plug into your PlantUML file, and now you talk about person and system and relationship. So this is, if you like, it's a more domain-specific language that talks about C4 diagrams. The problem with diagrams as code, in most cases, is that if you want 2 diagrams, you need 2 text files. Exactly the same way with Visio, you need 2 tabs, 2 worksheets. If you want to start copy and pasting elements because you want them included on both diagrams, you have to make sure that the lines are in both text files. If you rename one of those things, you have to make sure you rename it in both text files. Now, things like PlantUML do allow you to do !include, so you can potentially pull out snippets, include them from multiple files. And we can use our tooling to do global search and replace across a folder full of files. But fundamentally, if you want 2 diagrams, it's 2 files. So the responsibility to keep the files in sync is on your shoulders. I want to change the narrative. So I'm old, apparently. Back in the early 2000s / late 90s, I guess, there was this whole thing about modeling. Tools like rational rows. Who's used rational rows? Spot old people, thank you. Rational rows is like this big, expensive modeling tool. And it was very powerful. It was very ugly as well, but it was very powerful. And there's lots of good stuff you can do with things like a modeling tool. But when I say modeling these days, people go, rational rows. No. Like, we do agile. Rational rows is a relic from the waterfall days. And it's unfortunate because a model is essentially just a centrally defined dictionary of things. and then you can reuse those things across multiple diagrams. That's it. But the power of having a modeling tool is immense. And it solves many of the problems I've just already spoken about. So most of my income is through flying around the world and running workshops. And I wasn't able to do that during COVID because I got stuck on my island. Oh, it's not my island, but I got stuck on the island. So I basically did a lot of surfing, which is quite fun, but you can only do that so much hours a day. But I created a bunch of tooling to solve many of these problems. And the tooling I'm going to show you today is called the Structurizr DSL. This is an open source text-based domain-specific language specifically targeted and designed to create C4 model diagrams. What you're doing here is you're crafting up a single definition of everything, and you're using tooling to automatically generate you diagrams off the back of the things contained in that text file in that model. So this is fundamentally a text-based, model-based approach to diagramming. And I've tried to make it nice and lean and lightweight with a bunch of extensibility points I'll talk about later. This little snippet here, the screenshot, I'll let you read it. This is the problem with tools like PlantUML. It's nice and easy to get started, but once you want to start spanning and scaling across teams, or you want to model your whole enterprise, your whole portfolio of systems, it leads to lots of duplication, and it becomes quite complicated. So I see people jumping on C4 PlantUML because it's easy, but they run into issues very, very quickly. So that's another reason why I kind of put this tooling together. So essentially, this is models as code, or rather C4 models as code. I'm also calling this diagrams as code 2, just to differentiate it with things like PlantUML. A change for 2023 is that everything I'm going to show you is completely open source. So I went through a big exercise in January, February, March this year to open source literally the entirety of this tooling. And there are lots of plugin points as well. So the Structurizr DSL is open source. It's all on GitHub. That is a wrapper around an existing library called Structurizr for Java that I wrote actually 5+ years ago. There's a bunch of command line tools I'll show you quickly, which is also open source. There's a thing called Structurizr Lite, which is a Spring Boot application that comes pre-packaged as a Docker image that you can use and boot up and view diagrams. There's an on-premises installation, and there's a bunch of export utilities for different formats. So I'm going to kind of show you all of that stuff. So enough of the slides. Let's jump into the demo. So to show you that I'm not cheating, here is my desktop, which is currently empty, which is a result in itself. So I'm going to start up Structurizr Lite, which is this Spring Boot thing provided as a Docker container. Structurizr Lite, when you start it up, you do two things. Number one is a volume mount, and number two is a port map. So it's just a bog standard Docker thing. So I'm going to start Structurizr Lite. That script is going to do a port map to localhost 8080. And the parameter I'm going to pass here is the volume mount. So I'm going to mount a folder that doesn't yet exist on my desktop called NDC and pass it to Structurizr Lite. So we start up Structurizr Lite, and hopefully this all runs. We go to the web browser. We go localhost 8080, and we have, drumroll please, a diagram. So this is Structurizr Lite now running in the web browser. It's a Java Spring Boot app with a whole bunch of JavaScript SVG stuff running in the browser on the client side. So here we have a user somehow using a software system. So where did this come from? If we go back here, now we can see this NDC folder has been created, and inside is a DSL file. This is the Structurizr DSL. What we're doing here is we're defining a workspace. A workspace is essentially a wrapper for two things, a model and a set of views. The model is where we define our people, our software systems, our containers, our components. So we're defining a person with the name user, we're defining a software system with the name software system, and we're defining a link, a relationship between the user and the software system with a description of users. So that's my model. Then we are defining a system context view from the C4 model. We are defining a system context view for the software system, and this is just a diagram identifier. We're saying it includes star. What does include star do? Include star says includes the software system and include everything that is linked or has a connection to that software system. and apply automatic layout. So that gives us this diagram. And now we can do things like, so I don't like automatic layout. I think it's useful if you have diagrams with like 3, 4, 5, 6, maybe 10 elements, but in many cases, automatic layout doesn't actually work very well. So I built this tooling with manual layout in mind. So let's show you that. I'm going to comment this out, save it, go back here, refresh. Now we have a bunch more toolbar options, and we can start moving boxes around. So this is how I prefer to use the tooling myself. You can start breaking lines and changing line routing and all that sort of stuff, and it will save it here. If I rename this thing here to be called a business user, save it, go back here. So there's an algorithm built into all this tooling that tries to retain the layout that you created manually. Some of you might be thinking, well, hang on a second. Where is the layout? Where are the XY coordinates for those boxes? The answer is they're in this JSON document. So this JSON document is really the canonical data structure used by all of the Structurizr tooling, and it's really just a different version of that same information. So here we can see all the people defined in our model. Here's the business user and a bunch of properties. Here is the software system. And here, if I keep scrolling down, we can see things like the elements, their XY coordinates, vertices on links, that sort of thing. So what you do now is you take this whole folder, you commit it to source code control, along with a script to start Structurizr Lite, and now anybody can bring this up on demand and see this exact same diagram. So let's go back here. Let's turn on automatic layout because it works better for demos. I'm going to go back here, refresh. Now we have our automatic layout version. So the first problem we have with this diagram is that it's just two very boring gray boxes. So let's add a bit of pizzazz to these diagrams. How do we do that? Pizzazz, yeah. I'm going to turn on tooltips, and you can embed a bunch of metadata inside the DSL and add your own metadata that shows up on the tooltips. So you'll notice here that this business user element has two little things in text. This is element and person. These are text-based tags. The software system has an elements tag and a software system tag. The person has an element tag and a person tag. If for any of you who are kind of front-end developers, you know HTML, this is like CSS classes for your HTML elements. And what we can do is we can add styles for these text-based tags. So let's do that and change some things. What I'm going to do now here is add a styles section. Let's move that up a bit. I'm going to create an elements style for the elements tag. So this is going to get all elements. And let's go background green, color white. Go back here, refresh. So now we have white on green. If we want to change the shape of this business user to a person, what we can do is we can do the same thing. We can say create an element style for the person tag, shape person. There we go. So that's a really nice way to start styling all these things consistently. So imagine we've drawn our wonderful looking context diagram and we're super happy, and now we want to zoom in to that software system and draw the container diagram. As I said, with tools like PlantUML, now you spin up a second text file, off you go. With this tooling, what you do is you go up to here, you open up a set of curly braces, and you start typing away. So let's have a web application, which is going to be a C4 model container, and that's going to be called web app. Oh my goodness, I can't type at this angle. Let's have a database, why not? Classic architecture, of course. So we have a web app and a database sitting inside the software system. I know I've just drawn all of your architecture diagrams in one go. Thank you. And we're going to say there is a link from the user to the web app, and we'll say users as well. Please don't do users yourself. And we're going to say there's a link from the web app to the database, and we'll say reads from and writes to. So if I save this and go back here and refresh, what's going to happen? Nothing. The answer is correct, nothing. Because we've added elements to our model, but we've not created a view to surface to present those elements and turn them into a diagram. So how do we do that? What we do is we take this block, we copy paste it, we're going to change that to container. So we want to create a container diagram for that software system. So that's fine. This needs to change because it's a diagram identifier. Include star is fine. So what include star here does is it says, include all of the containers inside that software system, in this case the web app and the database, and anything that links to them. So that will hopefully bring in the person as well and apply automatic layout. So now we can save it, go back here. So now you'll see there's a little plus symbol here. If we double click this, now we get to the container diagram, showing the user has a link to the web app and the web app has a link to the database. So a couple of things I want to show you. I've defined this link, this user's link between the user and the web app, and this link at the upper level between the user and the software system. And this is really it's a violation of dry, isn't it? Don't repeat yourself. We've essentially repeated the same information twice to have that link show up on two levels of detail. I don't want to do that. I want this tool to be smart and help me do things. So what I'm going to do is I'm going to delete one of these lines. Now, you have to delete the correct line. And let's hope I get this right. I'm going to delete this one. I'm going to go back here, save it. So this is the line that's now defined in this text file between the user and the web app. That one there. If I go back here, that line still exists. So this is a feature called implied relationships. Because there's a link between the user and the web application, and the web application is a container inside the bigger, high-level software system abstraction, there is an implied or an implicit link between the user and the software system. So this tooling knows it's missing and it kind of adds it for you. And this is all customizable and you can turn it on, turn it off, customize it however you like to, but it's a really nice feature that stops you having to write lots and lots and lots of different relationships. What I want to show you now, let's make this a database shape, because why not? If I go back to tooltips, so this web application has an elements tag and a container tag, and so does this database. In order to style just the database, we're going to need to add our own custom tag to that database element, so then we can add a style for it. So let's do this in 2 goes. We're going to take this database, tags, let's just say database. So now if I save this, go back, refresh, tooltips on, hover, now we can see there's a database tag there. And now we can do essentially the same thing again. We can create an element style for the database tag. Shape is database. No, it's not a cylinder. If we now want to make all containers a different color, we can do that as well. So they're like CSS styles. These styles kind of cascade and override. So we can create an element style for the container, and we can say background sea green. Does that work in HTML? Let's find out. Yeah. So then we have slightly different color greens for the containers. One of the things I said at the start was, if you're going to use boxes and arrows, make sure you do it in a structured way. That's what the abstractions bring you. And try to make your notation self-describing. So what's missing from this diagram is a diagram key explaining what the different shapes and colors are. But I have your back. There we go. So this tooling will automatically generate you a diagram key based upon the tags you have on your elements and the styles that you have in your DSL file. And there's lots of shapes and colors and border styles that you can do, and you can also style relationships with dashed arrows and solid arrows for, synchronous versus asynchronous, unless you went to Sam Newman's talk and you're really confused now. But there's lots of stuff you can kind of do here. I saw it last week in CraftConf. It was fantastic. So that is the Structurizr DSL and Structurizr Lite in a nutshell. So I'm going to show you a few more things. I'm going to open up a new tag and go to structurizr.com/DSL. This is it's a little demo page on my hosted cloud service. What I'm going to do is I'm going to take this, I'm going to paste it into this left-hand side and click render. And this is going to give us the same diagrams that I just showed you with the Structurizr Lite tooling. So if you want to try any of this tooling out, structurizr.com/DSL is the place to go. I've also built a bunch of export utilities. And that's one of the nice things about the Structurizr DSL. It's rendering tool independent. So I showed you my Structurizr Lite tooling, which is an in-browser JavaScript SVG rendering engine. I've also built a bunch of tooling that allows you to export your diagrams to PlantUML. So this is a PlantUML version of that same container diagram. Here's the PlantUML text it gives you. That will also generate you a key. we go. There is also an export for C4 PlantUML. So by default, C4 PlantUML uses the standard, in air quotes, gray and blue boxes, but we're going to know that's not the case. You can change this. So if I go here and I go properties, don't worry if you can't read this, C4 PlantUML.tags true, and click render. Go back here, this will hopefully be different now. Yeah. So there's a way you can customize these things. It's all open source, you can do what you want to. There's also an export that I pre-built for Mermaid. So this is a Mermaid version of that same diagram. There's a dot for GraphViz version if you have dynamic diagrams. So this tooling also supports dynamic diagrams and deployment diagrams, a bunch of other things as well. So this is an example of this tooling being rendering tool independent. This is the demo page, but the CLI tooling I built basically integrates all of this tooling into one place. So what you can do is you can go to a command line. Let me shut this down. You can say run the CLI. We're going to do an export. The workspace is going to be that file on my desktop, NDC Workspace.dsl, and the format is going to be PlantUML. What have I done? Users, Simon, desktop, NDC Workspace. What have I done? It's there. No, it should work on the young one. I know you love demos. The file that definitely exists, doesn't it? Okay, so my tooling doesn't work. There we go. But if it did work, you could export using the CLI into various formats. I have no idea why it doesn't work. Anyway, moving on. So what I'm going to show you now is another example with Structurizr Lite against a different example. Hopefully this will work. So the example diagrams you'll see on c4model.com are the setup diagrams for an internet banking system. So I'm going to boot those up for you now in Structurizr Lite. So starting at the top, this is the system landscape diagram you'll see on the c4model.com website. Double-click, get to the context diagram. Double-click, container diagram. Double-click, component diagram. So those are the kind of the basic C4 diagrams with lots of new styles and shapes and things. This also does dynamic diagrams. So if you want to show how a specific use case or story or feature works, you can kind of step through and it's all nicely animated. And this also does deployment diagrams where you can show how things are deployed onto infrastructure. So here we've got the web app and the API app running in Tomcat on a Docker container on a developer laptop. So you can build up all this model using the DSL as well. Tooltips, et cetera, et cetera. So that's Structurizr Lite. What I'm going to do now is shut down Structurizr Lite and show you another tool called C4Viz against that same example. Now, this is another open source tool. It's kind of like a Structurizr Lite clone. It doesn't always work on my laptop. And I don't know why, but we'll give it a go. It sometimes gets stuck here. I'm going to suggest this one's not going to work. I don't know why it doesn't work, and when it doesn't work, you have to go into Docker Desktop, dashboard, and you have to kill it, and then you have to try again. And then it'll get stuck again, and I'll have to repeat the same thing, and we'll abandon this one. But essentially, this is a Structurizr-like clone. It's an in-browser thing, but it's not using my JavaScript SVG renderer. It's using PlantUML as its renderer. So let's sack that off. It's not going to work. So that's C4Viz. You can find it on GitHub. I'm going to show you another tool called the Structurizr Site Generator. I'm going to point it at the same folder, the Big Bank example. So this one will hopefully work. So this is Structurizr Site Generator. What this is doing is just generating you a kind of HTML microsite based upon the information in that workspace. If you've embedded Markdown and ASCII documentation as a part of that workspace, it'll be rendered in your browser. What you can do is you can go Systems, internet banking system. So you get your description of the internet banking system, and it kind of has all of the views in one place. So again, this is kind of like Structurizr Lite, but it's showing you the same information in a different kind of organizational structure. So here's the context view for that internet banking system. And they've hyperlinked it, so if I click that, we can go to the container diagram. If we click this, we can go to the component diagram, et cetera, et cetera. So this is using the C4 PlantUML renderer. So again, this is another way to kind of have all this information displayed and rendered in a different way, which is quite nice. So let me shut that one down now. I'm going to boot up Structurizr Lite again against yet another example. Let's go there. So something you can do here is you can embed Markdown and ASCII documentation as a part of this whole thing. So then you have all of your documentation and your diagrams all in one place. Commit that whole folder to source code control, along with your source code, and kind of all your artifacts are sitting in one place. So if I go back to here and go to Structurizr Lite, this is a different example. For anyone who's been in my workshop, I use a financial risk system as our case study. This is like an example piece of documentation for that financial risk system. So this is Markdown documentation now being rendered in your web browser. Let me show you the source so you know I'm not cheating. So this is the folder. This is the Workspace file. Same thing we've already seen before. We're defining a software system for the financial risk system. This exclamation mark docs basically says include all of the Markdown and ASCII documentation in that docs folder. That docs folder looks like this. It's just standard Markdown. I should just double click that really, shouldn't I? There we go. So this is just standard Markdown, with the exception of this little thing here, which is an image, it's an image, but I'm using the syntax embed, and then that's the context diagram from that workspace. So that diagram identifier I showed you before is the reason that thing there. That's the reason they have to be unique, so you can include these things later.
How large is this file?
How large is this file?
So large, okay, that's not much.
80 lines. There's a way you can do includes and workspace extensions, and there's a way to modularize these files as well to prevent them getting large. And I'll talk briefly about that later. So here we're basically saying include the docs, and yeah, this is all rendered in the browser. So here you have a nice way to include diagrams inside your Markdown documentation. This is the live version, so it also has things like the diagram key, and you can click to see the diagram, etc., etc. You can go full screen. So that's a nice way to include those live architecture diagrams, potentially with additional metadata behind the tooltips as a part of your Markdown and ASCII documentation. And it's all full text searchable, etc., etc. So that's documentation. Is anybody using architecture decision records here? Oh, that's only a small number. So if you've not looked at architecture decision records, thoroughly recommend it. It's a fantastic way to start capturing the architecture decisions that you're making on a potentially daily or weekly basis. There's lots of tooling out there to support ADRs. An ADR is typically a single Markdown or ASCII doc file describing a single decision, like we decided to use this version of a framework for these reasons. Check them in source code control, and then all of your decisions are in one place. The problem with ADRs is that once they go into source code control, they're forgotten about. You just have a folder full of Markdown or ASCII doc files. So what I did with this tooling is same thing. You can also say exclamation mark ADRs, ADRs. So in this case, it says pull in all the architecture decision records in the ADRs folder. And here we have a folder full of ADRs. This is all created using NatPrice's ADR tools tool. So that's what an ADR looks like. And this tooling, Structurizr Lite, will render them for you in the browser. So here we have a nice summary of all of the architecture decision records. It's all text searchable. We can scroll through them, etc., etc. So this is a really nice way to search and visualize your ADRs. One of the things you can do with ADRs is you can start superseding previous ADRs. So therefore, what you're doing is you're actually building up a network, a graph of ADRs and the decision paths as it progresses through your delivery lifecycle. You can show that with this tooling, so it will start linking things together to show you where you've started superseding older versions of decisions and things. So that's that kind of tooling. One of the big questions I always get with C4 and specifically tooling is, well, all your example diagrams only show like 6 boxes. Yes. How do you make this work for actual systems that are more than 6 boxes? Okay, so let me boot up another example. Let's see how many Docker containers we can get running in an hour session. So I'm going to boot up another example. This is a microservice-based architecture. And hopefully Sam's not here to tell me off if this is not true. So I'm going to open up a new tab, go to Structurizr Lite. So here we have, imagine we have a service-based architecture. What do I mean by service? So one of the things that C4 kind of forces you to do is to get more precise and specific with the words that you're using. Although many people talk about a microservice-based architecture, in many cases, an individual microservice is actually something like an API thing. It's maybe like a ASP.NET MVC API thing talking to a SQL Server relational database schema. So maybe those two things are what we mean by a microservice. So what this diagram is showing you is essentially all of the API things and all of the database things, and I'm using this grouping to say this pair of things is service 2 in this case. So imagine you have a service-based architecture. Here we have 8 services, and I'm using different color codings for different services. Again, this diagram kind of works okay. This is created using automatic layout. But you can now see as we add more services, this diagram is going to get more complicated quite quickly. So how do we solve this problem? Well, this diagram is showing you, it's one diagram showing 8 services. What we could do instead is draw one diagram per service. So maybe we have 8 diagrams, each focused on a single service only. And that's what we can do here. So here we have the service 1 diagram, which is showing you service 1, the things coming into service 1, and the things coming out of service 1. So it's inbound and outbound dependencies, the afferent and the efferent couplings, if you want to use those terms. Here is the the service 2 version. So it's things coming into service 2, things coming out of service 2, rinse and repeat for service 3, 4, 5, 6, etc. With a tool like Visio, how do you do this? You open up 8 new tabs, and now you start copy and pasting boxes and arrows across all those things. And then you realize you mess up somewhere, and you have to start changing things and keep them all in sync, and it gets an absolute nightmare. So this tooling, because it's model-based, it means you can do some interesting stuff. So let's go back here. This is the folder, the services example. So here we have, it's a DSL file. To answer the question of how long is it, this is 168 lines. So here we're defining the software system. This is service 1. So service 1 is basically a grouping of the API thing and the database thing. Repeat for service 2, for service 3, for service 4, for 5, for 6, for 7. You get a picture. Here are all the relationships, so that's the model. This is the all containers version. So we're saying create a container view for that software system, include star, which is including all of the containers, therefore all of the services, and apply automatic layout. This is the service 1 version. So we're saying include service 1, include things coming into service 1 and things leaving service 1. So this is a really nice way. There's a nice expression language built into the DSL that allows you to kind of slice and dice the model up and show different things on different views. So you could do like include star and then exclude a bunch of things. You can say include everything of type container if you want to show container to container relationships between software systems. That's easy to do with this expression language. And this is all extensible, so you can build your own expressions if you want to later. So in terms of how do we make this tooling work and how do we make the C4 model work for bigger, more complicated software systems, option number 1, have lots of smaller diagrams. It's all trade-offs. The downside of having lots of smaller diagrams is you now lose some of that bigger context. And some people like having that bigger context. But of course, as you add more services, this diagram will get more cluttered, more complicated. So option 2 is to not use a traditional diagram. I know I talk a lot about diagrams and how to make diagrams look nice, but maybe a better option is to use a different visualization format. So if you boot up Structurizr Lite and you click this magic button, you'll get that. Now this is very therapeutic. This is a JavaScript D3.js force-directed graph. And it's essentially showing you exactly the same information, but it's doing it in a very different format. So we're using lots of smaller nodes here. This has tooltips. So if you had embedded documentation or metadata, you could see that on this diagram. You can start clicking around things to show nearest neighbors. So if you want to say, hey, what does service 1 have a dependency on, you can use this exploration to find information very quickly. And there's a quick find feature as well, for example. So this is option 2. It's to use a different visualization format. We're still using the same C4 types, and we're still using the same C4 diagram type, but we're visualizing it differently. So that's option 2. Option 3 is to use the Structurizr CLI to do an export to another tool. Now, since the CLI doesn't seem to be working for reasons I have no idea why, I'm going to cheat, and I'm going to take this example. I'm going to open up yet another tab, go to my DSL demo page. I'm going to paste it across, get the same diagram we had before. There we go. And there's the graph, which is nice. We can do PlantUML as well if you want to. So all of these things I've shown you, they're all renderable with other formats, but that's not what I want to show you. I want to show you this one here. So there's a tool out there called ILO Graph. It's available at ilograph.com. Nothing to do with me. And it's a really nice tool that helps you to explore and visualize a hierarchical data set. And of course, this is a hierarchical data set. The downside of this tooling is that the input for this tool is YAML. And I can't stand here and recommend people handcraft a YAML. So I built you a way to get from my DSL to this YAML format, which is available through the CLI that doesn't work, or through this demo page. So what we can do is we can copy this into our clipboard, open up yet another tab, go to ilograph.com. We can go new diagram. We'll ignore that. We'll put mine in. We'll click static structure. So this is the same information now in the ILO Graph tool. The nice thing about this tool, and the reason I like it, is because it is interactive. So now we can start clicking around, and it kind of zooms into the thing you've clicked on to show you scope. And now you can see kind of nearest neighbors, et cetera, et cetera. So this is another really nice tool that helps you explore, navigate, familiarize yourself with a larger architecture. If I go back to my demo page, and I go to the big bank example, the internet banking system. So here's my set of diagrams for the internet banking system. Same thing, I can go to the ILO Graph export. Go to ILO Graph, go new diagram, go in there, delete it, paste mine in, minimize that, go static structure, there we go. So this is another view of that internet banking system example. It's showing you everything. It's showing you people, systems, containers, and components, all as kind of nested constructs. And again, we can start zooming in and figuring out what's going on and clicking around. So this is a great tool for manipulating and visualizing and exploring a kind of larger data set, which is quite nice. So essentially, you have lots of options. You stick with the abstractions, you stick with the diagram types, but you use different tools to visualize them and therefore explore them. What else did I want to show you? A couple of different things. So all of this tooling is built in Java. Who's a Java developer here? I'm going to suggest this is nobody. A couple of people. Cool. Okay, so for the 2 Java developers here, welcome. I found my people. All of this tooling I've built is written in Java. There's a Java library. It's all on Maven Central. The DSL parser is also a Java library. So if you have the ability to write Java code, if it's something you're using on a regular basis, you can add yourself a dependency to my DSL parser. You can create yourself a DSL parser. You can parse the DSL file, get the workspace out. This is like an in-memory representation of the workspace. And then you can start doing things like find the web app container and add components to it. So what you could do here is you could craft up your high-level definition of your architecture, maybe people, software systems, containers in the DSL, and then load it through the code libraries, and now start adding components. Why might this be useful? Maybe you want to use Java's reflection mechanism or static analysis to go and automatically generate a component diagram from your real code base. Maybe you want to scrape your AWS environments, your config files, to pull in a config file and generate a diagram of your AWS environment. Again, you can use this tooling to do the same thing. None of that is available out of the box, but we're developers, we can write tooling to do that. So if I run this little demo, hopefully this will work. Otherwise I'm in real trouble. Yeah, so here we're basically just printing out all of the elements in that workspace, and we added this logging component, which is why it's showing up in the output. So that was the demo for the 2 Java developers in the room. Who's a .NET developer? Yay. So there is a version of this library called Structurizr for .NET. It's something I wrote a number of years ago. It's mostly up to date. It mostly supports the same features as the Java version, but there is some stuff missing. It is open source, so you can issue pull requests if you want to. There's no DSL parser in the .NET version. But what you can do instead is you can point it to the JSON version, so I'm going to change that. So the JSON version is created for you by Structurizr Lite, but again, you could also use the CLI to export the DSL to the JSON file. Now you have the JSON file, you can use the .NET library to load the JSON file, get a workspace, and then we can do the same thing. We can say, find me the software system called software system, find me its container called web app, and add a logging component to it, then print everything out. So hopefully this will work. There we go. So now you have, again, a bunch of ways to craft up a high-level definition in DSL, loads the resulting workspace in your tool of choice, in this case .NET, and then you can do stuff to it. So this library is built to be append only. So you kind of craft up a high-level version, and then you add and append things using the code-based libraries if you want to. So that's pretty much all of the tooling. There's a whole bunch of other stuff you can find if you do a search for Structurizr on GitHub. People have built all sorts of tools, integrate into their build processes. They built GitHub Actions to generate diagrams. It's all scriptable, and again, all of this stuff is open source. So I have 2 slides I would like to show you. There's a whole bunch of stuff I've not shown you. The first of these features is called Workspace Extension. Something a lot of organizations want to do is they want to craft up a single Structurizr workspace defining all of their people, so users, and all of the software systems that exist in their organization. And then they want individual teams to extend this workspace and add in the container and component details for the systems they are working on. So this is a nice way to do this. Essentially, you can have a single workspace, which is your system or service catalog, and then you have every team kind of extend it and add their own information. I see lots of people these days using things like Spotify's Backstage or their own internal service catalogs. Again, you could build some integration that scrapes all of your software systems and services from Backstage, from your service catalogs, and then kind of you do the drill down one C4 model set of diagrams per team, for example. There's also a way to modularize this, so if you want to have fragments that you include in various places multiple times, you can do that. Because this tooling is all Java-based, there's the ability to write short scripts, either inline or in included files in JVM scripting languages, which is only useful for the 2 people who do Java over there. Kotlin, Groovy, JRuby are all supported out of the box. And again, for the Java people, there's the ability to write bigger plugins using Java and therefore have all of the IDE support as well. And again, all of that's documented. So if you want to get started, you can go to structurizr.com/DSL. That's the DSL demo page, little text area on the left, multiple diagram types on the right-hand side. Lots of this documentation is sitting on GitHub. I've listed here some of the links to the other alternative rendering engines. The one thing I do want to point you to is if you go to the DSL GitHub repo, you'll see a link to the DSL cookbook. So what I've tried to do here is I've tried to add a bunch of here's how you might do a certain thing with the DSL. So here's an Amazon Web Services example. And it says, here's an example of how you want to describe your cloud architecture with Amazon Web Services. Nice, boring gray diagram. And perhaps we can start adding some themes and icons and that sort of stuff. So there are also a bunch of themes I've created for AWS, Azure, etc., which is all available on that demo page, which is structurizr.com/demo. And just to show you that in action, here's the AWS version. So here are the icons, diagram key, all generated for you. So this is another nice way to combine all this tooling and have cloud architecture diagrams that also make sense to more people. So thank you very much. Any questions? Yep, one here.
I was wondering, if you use something like Confluence for the invitation
So the question is, if you're using something like Confluence, how do you get these diagrams and documentation into Confluence? You have a bunch of options. So option one is you can craft yourself up a CI/CD build process that takes the DSL files, produces a bunch of PlantUML files, turns those into PNG files, and uploads them to Confluence. So that's one way. You kind of have to handcraft this set steps together. I have an on-premises installation of the Structurizr tooling, which is free, it's open source. So the difference between the Lite version and the on-premises version, they're both free, they're both open source. Structurizr Lite is like a single workspace at a time. The on-premises version allows you to publish or host multiple workspaces from a single server installation. There are a bunch of Confluence macros that I've also built, which are also on GitHub. And basically, the live embed is just a HTML iframe embed. So using the Confluence macros, you can do an iframe embed of that content of the on-premises installation. So that's option 2. Option 3, if you go to structurizr.org, which is a site, it's like the open source version of all of this. I've linked all of the tools I found that have some degree of support for this tooling. There's a company in the Netherlands called Avisi, and they have a collection of Confluence plugins. And they have this thing where if you have a Structurizr DSL file in a Git repo, you can point a Confluence page to that Git repo, and it will automatically render you the file you point it at. So that's another way to surface these diagrams in various formats on Confluence pages. So yeah, you have a bunch of options essentially.
Can you do that in GitHub as well? You have Markdown in GitHub, and you do Mermaid in GitHub. Can you do that as well?
So the question is, can you do this with GitHub and things like Mermaid? Yeah, but you'd have to build your own tool chain. So what many people do is they do GitHub action, look at the DSL file, commit, use the CLI, export to Mermaid, and then embed it in Markdown. Yeah. There's a question over here.
Thanks for this. It's really cool. Do you have a way to connect the ADRs with specific components, with specific containers?
Yeah. So the question is there a way to link ADRs to specific elements? And yes, when I showed you that ADRs example, it was nested inside the software system block. If you want to associate ADRs with a container, you nest the exclamation ADRs inside the container block. And yeah, that's all linked to that element in the model. Questions over this side? I think I'm ignoring this side, but I can't see you. Any questions over there?
Yeah, I've got one.
Yeah?
Can you make a plugin for Backstage?
No? But feel free to. So if you go to Backstage's repo, there are some people who are asking, like, how do we make Structurizr integration with Backstage? I don't know how to do it. And the complexity with integration with Backstage is they have a slightly different version of what a software system is. So you'll have to do some sort of like bounded context kind of mapping. But yeah, it's certainly possible. But I'm afraid I can't do it for you. It was worth a try. Any other questions? Yeah.
What about existing code?
What about existing code?
Yeah, we want to extract some whatever diagram, whatever that would help start.
Yeah, so if you have like an existing C#.NET code base and you want to automatically generate a component diagram from it, you'll need to write yourself some tooling that will use .NET's reflection or some static analysis techniques. So I'm not a .NET developer, as you might have guessed, but previously I believe you could do this with things like Roslyn. Does Roslyn still exist? Is it Roslyn++ now? So you could use those tools to go and find yourself components in your code base and then add them to a container in this model.
Remember the question, is there any import into this from you showed only export?
Is there any import? Oh, to import existing diagrams? Yeah. Oh, no. So if you have an existing catalog of, say, C4 PlantUML diagrams, there's no way to convert those to Structurizr DSL. Any other questions? One here at the front, yeah.
Was it like you can include Structurizr into C# project and then generate components from there? Or was it...
So there's no way to generate C# components from the Structurizr tooling, but you could write that sort of functionality if you wanted to. But from my perspective, this is a go the other way. So if you have an existing code base, you turn that into a diagram rather than for generating code. Cool. Well, thank you very much. Any more questions afterwards? Come grab me.